lesson 2.8. At the end of this video, you should be able to graph two variable inequalities. Okay, to graph an inequality, what you're going to do is graph the boundary line, which just means graph the line that you're used to, slope-intercept form or something, or absolute value. And then the second thing is new. You pick a test point that is not on the boundary line, and you plug it into the inequality. If the test point is true, you shade that side. If it's false, you shade the other side. So, for this first one, this is in slope-intercept form. So, this is my M, this is my B, and I'm just going to graph it just like it were a line. So, I graph my y-intercept first. That's -1, so I put a point on -1. Then I use my slope, and I'm going to go up 3 over 1 and put another point. And then I'm going to do it again. And I can do it again. And I can actually go the other way. And I have a good solid line that points that I can draw my line through. A better line than that. Okay. Now, the next thing is to pick a test point. You want to pick a point that is obviously on one side or the other. So I'm going to choose this point right here, -1, 1. And that's going to be my test point. You always want to choose small points. That way, when you plug them in, you don't have to get big numbers. And then you just plug them in for x and y. So you get 1 greater than 3 times -1 minus 1, which is going to be 1 greater than -4, which is true. So you are going to shade that side of the graph. So wherever your test point is, that's the side you shade. Oh, and the other thing I forgot to tell you is when you graph it, if it is greater than or less than, that's going to be a dotted line. But if it's or equal to, that's going to be a solid line. So I need to go back and dot my line. So you just go through and make it dotted. Okay, example 1b, we have slope-intercept form again. So we just find our slope. That's going to be M right in front of the X there, and then the B is 1. So we're going to go up 1, put a point. Oops. And then our slope is -2 over 1. So we're going to go down 2, right 1, and put a point there. And then you just keep following your slope, and if you want to go the other way, you go up 2, left 1. Now you have a good bunch of points that you can draw your line through. This line is going to be solid because it has an equal sign up underneath it. Then you just have to pick your test point. So you're going to pick a point that is on one side of the line or the other. IC 0, 0 is on the left-hand side of the line or the bottom of the line, depending on how you want to look at it. So we're going to use the test point 0, 0, and we're going to plug it in. So we get 0 greater than 0 plus 1. 0 is not greater than or equal to 1, so I shade the other side of the line, which is going to be this side. Okay, the other thing I could probably tell you about this is if it's greater than, you're going to shade the top of the line. It's not so obvious here because the line is so slanted, but this is actually above the line, so you would shade this side. If it's less than, you would shade beneath the line. You don't actually have to pick a test point. There's actually a word problem that goes along with this example in your textbook, but I'm just going to show you how to graph the linear equation itself. And this one's in standard form, so you're going to use intercepts to graph it. Anytime it's in standard form, the best way to graph it is to use intercepts. So to find the x-intercept, we're going to let y equal 0. So we get 3x less than or equal to 60. So x is less than or equal to 20. And then to find the y-intercept, we're going to let x equal 0, and we get 5y is less than or equal to 60, which means that y is less than or equal to 12. And our graph that we have is not very well suited for our points. So since y is 12, let's do 2. Instead of the numbers that we've got here, let's do 2, 4, 6, 8, 10, 12. And instead of, since x is 20, let's do 5, 10, 15, 20 on the x-axis. Then graph those points, because that'll work better for the numbers we have. So x-intercept is 20. That's there. Y-intercept is 12. It's up there. And then you can graph your line. Anytime you have 2 points, you can graph your line. It always is better if you have more. See how curvy my line was? But you don't have to, and it's not supposed to be a curve, it's supposed to be a straight line. And then it has to be solid because my inequality symbol has an equal sign up under it. And now we pick a test point. 0, 0 is always the easiest test point, so we're just going to plug it in. And we get 0 is less than or equal to 60 when you plug it in, which is true. So you're going to shade that side of the graph, which on the graph we have is going to be this whole bottom side. And the little trick I showed you before, it's less than, so you're going to shade below the graph, which is down here. Alright, example 6, I have another inequality for you. This one is an absolute value inequality, which means it's going to graph a V. If you put it in the general form of an absolute value, you need to move this 1 over. So you get negative y is less than x plus 2 minus 1. Then you can't have negative y, so you're going to change all the signs, including the inequality symbol. Now you have the general form of an absolute value. So this is going to say it goes upside down, and I'm just going to graph it by transformations. This one says it's going to go left 2, and this says it's going to go up 1. So instead of my vertex being at 0, 0, we're going to go up 1 and left 2, and there's my new vertex. And it's going to open down because it says it's upside down. So my slope on my right hand side is going to be 1, and then you're going to match it by symmetry on the other side. And then you draw your V. Okay, because this is greater than, we're going to shade above it. But just to be sure, since we had to do flipping and stuff, anytime you have to change signs or anything, let's just be sure and let's check it. So we're going to pick a test point. 0, 0 is free, which means it's not on the boundary line, so I can plug that in. And I plug it into the original. So I'm going to do 1 minus 0 less than absolute value of 1 plus 2. No, 0 plus 2. My test point 0, 0. So it's 0 plus 2. And I get 1 is less than 2, which is true. So that still follows along with what I said about greater than and shading above the line, less than shading below the line. So I shade above my V, which is this area up here. Also, I was supposed to have a dotted line here because I have less than without the equal sign up under it. So I'm going to go through and dot my line. With a pencil, what I would do is draw my line and then erase parts of it. You know, if you forget, like I do a lot of times. I always look at the end, but I forget to do it in the middle. Alright, last example. We're going to do the same thing all over again. And we're still going to graph this absolute value by transformations. Because I have minus 4 over here with the y, I'm going to move that 4 over. So I get greater than or equal to 2, x minus 1 plus 4. I didn't have to turn my inequality around, and that also means that I'm going to shade above the graph whenever I draw it. So the 2 is my slope. The 1 and the 4 is my vertex point, so that's going to be opposite of that, and then that, so positive 1, 4. And then this time I'm not doing it by transformations, I'm going to do it by general form of an absolute value. So my vertex is 1, 4, so I'm going to write 1 up 4, put a point. My slope's going to be 2, so it's 2, 1, 2, 1. On the other side, up 2, left 1, up 2, left 1. Now you have your inequality. It does need to be a solid line. So I'm going to graph my inequality. And let's just pick a test point just in case. 0, 0 is free, so we'll use it. When we plug it in, we get 0 minus 4 is greater than or equal to 2 times 0 minus 1. That means negative 4 is greater than or equal to 2 times 1, which is 2. Negative 4 is not greater than 2, so that's false, which means I shade the other side of the line. Not where 0, 0 is, but the other side. And that happens to be above the graph, like I said it was going to have to be to begin with. Alright, here are your got it questions. I need you to do these on a separate sheet of paper. You do have to graph them, show as much of the work as you possibly can, and bring it to me tomorrow for proof that you did your homework.